So, having learnt RREF and so on, how they are used and so on, let us now go back to system of equation. That is the basic idea for us, trying to understand everything for system of equation. So, let us look at some examples again before I give you the main theorem. So, example about system of equations. We are going back to system of linear equations. So, our system of equation is Ax is equal to b, fine. We can talk of rank of AB and rank of A. So, what can be the relation? What I know is that RREF of A is nothing but what we learnt was this is equal to the first. So, A is m cross n, B is m cross 1, fine. The first n columns of RREF of AB. This is what we learned. Since A is nothing but the first n columns of AB, therefore, rank of A will have to come from RREF of A, which is nothing but what we know is that RREF of A will be equal to the first n columns of the RREF of AB itself, fine. So, therefore, rank of A will be either equal to this or rank of this will be equal to rank of A plus 1, fine. There is no other choice other than this, because we have added one column, this, fine. So, what we are saying here is that we are going to have this as AB has one extra column as compared to A, fine. So, rank of A, that is the rank of the coefficient matrix, can be either equal to the rank of the augmented matrix. So, what we are going to write is, so either rank of A is equal to rank of, or which is same as rank of coefficient matrix, is equal to rank of augmented matrix, or rank of A, which is same as rank of coefficient matrix, will be equal to rank of augmented matrix minus 1, fine. So, would like to look at this case first, all right. So, let us look at this case first, when the rank of augmented matrix is rank of A plus 1, all right. So, when I say that rank of A augmented matrix is rank of A plus 1, what does it mean? All right. It means that this will imply that there is a pivot in the n plus 1th column. Is that okay? So, this you have to be careful here, understand this nicely. What we had learnt was that RREF of A is same as the first n columns in the RREF of AB. All right. Therefore, we had proved that theorem that if I pick the first s columns, the RREF is just taken from there itself, fine. So, here what we are saying is that I have this matrix AB. So, A is here, B is here. The RREF of A will remain in this part itself. There is not going to be any change when I look at the RREF of. So, I am looking at RREF of AB. I am looking at this. So, this part is nothing but RREF of A, and this is something that I am having. I am not bothered what exactly it has, but what it says is that the rank is more. So, there has to be a pivot at the n plus 1th column. Now, there is a pivot means I have an entry here which is 1 somewhere, I do not know where 1 is, fine, because there is a pivot. So, there is a 1, and since there is a pivot, it means that in this row, this is the first non-zero entry, all right, fine. This is what the definition of pivot was. What was the pivot? Look at any non-zero row, the first non-zero entry in that row was the pivot. So, therefore, if this is the pivot, it means that the corresponding entry here in that row is 0, fine. And this tells me that this equation corresponds to looking at 0 times x 1 plus 0 times x 2 plus 0 times x n is 1, which has no solution, all right, fine. So, this is what you have to understand, that I will not have a solution as soon as rank of A B is greater than rank of A, or rank of the augmented matrix is greater than this. So, let me write it down. So, as a corollary or as a understanding of what we have done, if rank of the augmented matrix is greater than rank of A, then A x is equal to B has no solution. Is that okay? Fine. So, this is when B is non-zero, all right. So, this can happen only when B is not 0, fine. If B is equal to 0, then the last column cannot have any non, then the n plus 1th column of AB, then the nth column of AB is 0, or which is same thing as saying that AB is same as A0, implies the RREF of AB cannot have a pivot in the n plus 1th column, and this will imply that rank of AB will be same as rank of A, and we already know that for the system A x is equal to 0, x is equal to 0 is always a solution, fine, all right. Now, let us take another example to proceed further, all right. So, that was first example, second example, all right. So, let me write a small example and then build upon that idea. So, I will take a larger also. So, let me take AB as, I have some matrix AB, I am looking at RREF of AB, fine. So, RREF is going to look like, so now I am assuming the case that, so case rank of AB is same as rank of A, fine. I am taking this case, and B is not 0, and then I will go to B equal to 0, fine. So, let me write this. Suppose I have got this. So, 1 is a pivot. So, I have got 0 here, 0 here. There is another pivot at. So, I have got say 0 here, 1 here, 0 here, and I have got say 2 here, 0 here, minus 1, 2, 0, 0. So, this is my A part, all right, A part, and the B part is say 2, 3, 0. Fine. So, you can see that rank of A. So, this is satisfied, that you can see. This is the A part. Here there are 2 pivots, and there is no pivot in the 5th column. All right. So, this equation, if I look at, this corresponds to looking at x1 plus 2x2 minus x4 is equal to 2, and x3 plus 2x4 is equal to 3. From here I can write here that this implies x3 is equal to 3 minus 2x4, and x1 is equal to 2 minus 2x2 plus x4. Fine. This is very, very important. All right, have a look at it nicely. Fine. So, what exactly we are doing is, I have written x1 and x3 in terms of, so we have written, so let me write it, written x1 and x3 in terms of constant and x2 and x4. Look at the pivots. The pivots are here. This is a pivot and this is a pivot. Pivot is there, pivots in 1st and 3rd columns. All right. What we know is that every column corresponds to a variable. So, pivot 1 corresponds to the first variable x1. The second pivot in the 3rd column corresponds to the variable x3. So, what we are doing is that we are writing the variables corresponding to the pivots in terms of non-pivots. So, there is a notion here what are called basic variables and what are called free variables. So, what are basic variables? The variables corresponding to pivotal columns. All right. So, in this example, pivotal columns are 1 and 3. So, the basic variables are x1 and x3. What are free variable? They correspond to non-pivotal columns. All right. So, non-pivotal columns, those what are the non-pivotal columns? 2nd and 4. So, therefore, you have x2 and x4 here. Fine. And for the free variables, they were x1 and x3. Is that okay? So, what we have done here is that we have written, you have to be careful here, we have written free variables in terms of a constant which are 3 and 2, which are coming from the side B part, and the free variables. That is always important, because free variables can be given whatever value you want, and still the system of equation will have a solution. So, let me rewrite this in the next page now. So, what I have is my RREF of AB was 1 0 0 2 0 0 0 1 0 minus 1 2 0 2 3 0. Fine. X1 was 2 minus 2 x2 plus x4. X3 was 3 minus 2 x4. So, let us go back and rewrite it nicely now. All right. So, let me add the solution x as x1, x2, x3, x4. What we see here is that x1 is 2 minus 2 x2 plus x4. x2, there is no change in x2 because it is just a free variable. x3 is 3 minus 2 x4, and x4 is also free, I can leave it as it is. So, this is same as 2 0 3 0 plus x2 times minus 2 1 0 0 plus x4 times 1 0 minus 2 1. All right. So, look at these solutions here, look at this x, fine. This is obtained by, so this is the solution I have, this with x 2 and x 4 arbitrary. This is the solution I have, fine. I have written this in terms of this vector. Now, how do I get this? So, here I have taken from here to here, if I want to go, I have taken here x 2 to be 1 and x 4 is equal to 0 to get minus 2 1 0 0. This is the thing I got. Look at here, you put x 2 to be minus 2, forget about this constant part, you get minus 2 here, 0 here and so on, x 2 is 1, fine. So, here other than the constant you are looking at the remaining part. This corresponds to looking at x 4, put x 4 to be, so x 2 is equal to 0 and x 4 is equal to 1. So, x 4 is 1 in the first one, so you get to here, x 2 was already free variable, that is 0 already for us, and then minus 2 coming from x 3 and this one. Is that okay? So, I would like you to check here that this times 1 0 0, 2 0 0, 0 1 0, minus 1 2 0. This times 2 0 3 0 gives you this. Just multiply here 2 times this, 0 times this, 3 times this. So, you get 2 here, 3 here, 0, which is coming from the B part. Fine. What else? 1 0 0, 2 0 0, 0 1 0, minus 1 2 0. This times minus 2 1 0 0 gives me 0 0 0 0. Similarly, 1 0 0, 2 0 0, 0 1 0, minus 1 2 0. This times 1 0 minus 2 1 will also give you 0 0 0. Fine. So, these two, all right, these two vectors, they correspond to the solution of Ax is equal to 0. Ax is equal to 0. So, they are what is called corresponding to solution set of homogeneous system, all right, and this was what is called a particular solution of Ax is equal to B. Fine. Let me take a slightly more complicated one, bigger size, and then I will write the theorem. So, now I am looking at only Ax is equal to 0. I am not looking at, I am looking at Ax is equal to 0, Ax is equal to B I am not bothered about, because Ax is equal to 0 gives me all the ideas, all right. So, suppose my corresponding matrix A RREF of A is C, and my matrix C looks like 1 1 2 3 2 plus 3 5 1 2 3 4 5 0 1 2 1 minus 1 3 . Suppose this is the matrix that I have, all right. So, it is 5 cross 3 6 1 7, 5 cross 7, all right. So, how many variables I have? Since it has 7 columns, implies 7 variables or 7 unknowns, fine. What are the pivots? This is a pivot, this is a pivot, this is a pivot, this is a pivot, 4 pivots, all right. And if you look at the pivots, they are in the first column, second column, first, second, fifth and sixth. So, therefore, this implies that x 1, x 2, x 5 and x 6 are basic variables. Fine. This also implies that x3, x4 and x7 are free variables. Is that okay? So, when I want to write x as x1, x2, x3, x4, x5, x6, x7, what we have is, look at x1 from here, the first part. So, x1 is, it is coming from here, so minus 2 x3, then it is plus x4 and minus 2 x7. x2 is another basic variable. So, x2 is minus x3, minus 3 x4, minus 5 x7. Then the next is x5. x5 is plus 4 x7 and x6 is minus x7. All right, so let us write it back. Minus 2 x3 plus x4 minus 2 x7. x2 is minus x3 minus 3 x4 minus 5 x7. x3 there is no change, x4 there is no change because they are free variables. x5 is 4 x7 and x6 is minus x7 and x7 is again a free variable, so I keep it as it is. So, this is same as x3 times minus 2 minus 1 1 0 0 0 0 plus x4 times 1 minus 3 0 1 0 0 0 plus x7 times minus 2 minus 5 0 0 4 minus 1 1. Fine. So, now some observations. x3 was a free variable, all right. Since x3 is a free variable, this one appears at the third place. Is that okay? Look at the other places here, third places are 0, all right. Third places are 0, fine. Let us look at the next. Here you have x4, 1 at the fourth place, fine. So, since it is the fourth variable, x4 is the fourth variable, it corresponds to the fourth column. The fourth entry here is 1, here it was 0, here also it is 0, fourth place 0. Is that okay? You can see here, this also is 0 here, fine. The last one, this is x7. So, look at the seventh place, there is a 1 here, all right, and seventh place here everything is 0. So, when I am looking at the solution here, fine, there were 4 basic variables or 4 pivots, or rank of A is 4, fine. So, therefore, 7 minus 4, which is 3, was number of free variables. Each of these free variables have given me a solution set, in the sense that I have got this vector which is a solution of the above system. You can see that minus 2 minus 1 1 times that will be 0. So, what I am saying is, just look at minus 2 times the first column, minus 1 times the second column, plus 1 times the third column, just add these 3, minus 2 plus 2 is 0, minus 2 plus 2 is 0, minus 1 plus 1 is 0. So, you get a solution of Ax is equal to 0. Similarly, verify that this is also a solution of Ax is equal to 0 and this is also a solution of Ax is equal to 0. Is that okay? So, what we are seeing here is that they have some nice properties, and not only that, they correspond to, in some sense, 1 0 0 0 1 0 0 0 1, all right. But now it is with respect to the rows that you are looking at. We are forming the rows 1 0 0 as the first row coming from x3, coming from x4 is 0 1 0, and from x7 you are getting 0, 0, 1. Fine. So, now let me conclude this by giving the statement of the theorem. So, what is the theorem? Theorem, let Ax is equal to B be a linear system in n variables, fine, with RREF of AB is equal to CD, then what if rank of AB is greater than rank of A. So, rank of the augmented matrix is greater than the rank of coefficient matrix, implies the system has no solution. So, note that when I am saying that this is greater, it means that B is non-zero directly, because you are saying that there is a pivot at the bth place. So, you are already saying that B is not equal to 0, and there is a pivot in the n plus 1th column, all right. And therefore, you have the system 0 times x1 plus 0 times x2 plus 0 times xn is equal to 1, no solution. Fine. So, now the case is when they are equal. So, if rank of AB is equal to rank of A. Now, here we have two cases, case A, rank of A is n, which is number of variables, all right. So, since the rank of A is n, it means that there are n pivots, implies all variables are basic variables, implies no free variable, implies unique solution. So, look at it from this point of view. B is there, so B will have some entries, fine. Now, you are saying that rank is n. Rank is n means there are n pivots, and not only that, rank is n also means that I have got I sub n. So, I sub n is there in C, all right, because CD was the matrix RREF. So, this is my C part, and we are saying that IN is there. So, IN is there means I have got 1 here, 1 here, 1 here. So, this one, every column has a pivot, all right. If every column has a pivot, it means that I already have x1 is equal to this, x2 is equal to this variable. So, if this was d1, this was d2, we are already saying that x1 is d1, x2 is d2, x3 is d3, and so on till xn is dn, whatever it is, fine. Because this matrix was D for us, this was the C for us, fine. So, there is a unique solution, and this also means that m is greater than or equal to n, all right. So, that we are not saying, but since we are saying rank of A is n, that implies that part, all right. The third part is, not the third part, but the B part of this is rank of A is strictly less than n. Suppose this is R. So, this will imply that there are R basic variables and implies n minus R free variables. This will have infinite number of solutions. And each free variable is going to give me a vector. So, each free variable gives a solution of Ax is equal to 0. So, suppose the free variables they give you vectors. So, u1, u2, u of n minus r, all right. So, there are how many free variables? N minus r free variables, and therefore, you have got n minus r vectors. Is that okay? N minus r vectors. They have some nice form in the sense that they have got, if I look at u1 will have 1 0 0 somewhere, u2 will have 0 1 0 0 0 and so on. So, there will be n minus r vectors, and a of ui will be 0 for 1 less than equal to I less than equal to n minus r. Is that okay? We will look at the implications of these ideas in the next class, all right. So, I want you to understand that whenever the system of x equal to b, whatever m size, the whole thing, the whole argument is independent of choice of m. It is only dependent on rank of augmented matrix, rank of A, and the number of unknowns. It has nothing to do with m. That is all for now. Thank you.